Hello everyone, and this is a video tutorial about a battery's own internal resistance. Now, an ideal battery, that marker's done, an ideal marker never runs out. An ideal battery is one that has no internal resistance. So the EMF that they give you for a battery, let's say it's 12 volts, well that means that it has no resistance, so the voltage that it would give would be 12 volts. But sometimes batteries have an actual internal resistance. And here's how you can figure that out. So imagine our battery, here's our positive and here's our negative, and it's connected to a resistor. And let's say that the battery has an EMF of 12 volts. And let's say that I have a resistor here that is 6 ohms. Okay, and let's say that you measure the voltage across here and it's not 12 volts. Let's say you measure the voltage here and it's 10 volts. Ugh. Well, that means that if you think V equals IR, well, my R is 6 and my voltage is 10. Well, that gives me a current of 10 over 6 or 5/3 of an amp. And that's how much current is actually being drawn out of the battery. But my EMF is 12 volts, which means the voltage across this resistor should be 12 volts, which means my current, if you think V equals IR, if that were 12, my current is, or excuse me, my resistance is 6, I should have a resistance of 2 amps. But I don't. I get a resistance of, or excuse me, a current of 5/3 of an amp, which means there's internal resistance going on here. Here's how you figure this out. If this battery has resistance, it still abides by Ohm's law, V equals IR. So, its EMF minus its current times its resistance will equal what's called the terminal voltage. The terminal voltage is what is the actual voltage across this battery. This is its ideal voltage. You take away its current times its resistance and you can get the terminal voltage. Its current is 5/3 of an amp. We don't know the battery's internal resistance, but we do know that it has a terminal voltage of 10. So over here, I've got 12 minus 5/3 times R equals my terminal voltage, which in this case is 10. So I would subtract 12 to the other side, multiply both sides by -1, and I would get 5/3 R equal to 2. Well, then I just multiply both sides by 3/5. I get 6 over 5 R. So that would be the battery's own internal resistance, 6/5 of an ohm. This right here is your bread and butter for internal resistance problems.